Trigonometry. Basically, what trigonometry is, it is a measurement of triangles, its sides, angles in a right angled triangle. So that we have a right angled triangle. Angle be ABC, which is right angled at B. So A and C are the acute angles here. So the angle which is opposite to 90 degree, the side which is opposite to 90 degree, we call that side as hypotenuse. So the side which is lying on the base is called base, and AB is a perpendicular, or when I look these things from the angle C, this AB side will become opposite, and the base can be considered as adjacent adjacent to the corner C or to the angle C. So we use the symbols like theta or phi or alpha, even beta or gamma to represent these acute angles. So now the three sides and three angles give 6 trigonometric ratios. Based on the three sides and the three angles, we have 6 trigonometric ratios. They are sine, which can be simply termed as sin, with reference to the angle theta c. Sine is the ratio of opposite side divided by hypotenuse. Which means from the C, if I look at opposite is AB and the hypotenuse is AC. Similarly, I can move on to the further ratio, that is cosine, or which can be called cos of angle C or cos of angle theta, which is adjacent side divided by hypotenuse. So that will turn to be BC divided by AC. So further continuation, I have tangent of an angle, or can be written as tan theta, that is opposite side by adjacent side. Therefore, it is AB by BC. Then we have cosecant theta, cosecant of the angle, or can be cosecant or simply written as cosec theta, that will be hypotenuse divided by opposite side, which means it is the reciprocal of the sine. We can see here sine is opposite by hypotenuse, cosecant is hypotenuse by opposite, therefore it will become AC by AB. So which can also have a mathematical relation, that is it is 1 by sine theta. We left out with two more ratios, that is secant of an angle can be written as SEC theta, secant theta, which is equal to hypotenuse divided by adjacent. So hypotenuse divided by adjacent side forms AC is our hypotenuse here and adjacent is BC. So by this comparison we get this is 1 by cos theta. And the last one we have is cotangent or cot theta, which is adjacent side by opposite side. Looking into the triangle, adjacent side is BC and opposite side is AB. So comparison of this will give tan theta is 1 by cot is 1 by tan theta. So this follows an additional relation. Tan theta can be obtained by sin theta by cos theta and cot theta is cos theta over sin theta. Let's solve few questions based on this simple trigonometric ratios. So I have a question. The three sides and three angles. Six ratios. The three. I have a right angle triangle. ABC with the measure AC being 13 centimeter and BC being 5 centimeter. So find sin A. So sin A means I have to verify from this side. So for that the opposite will be BC. So to find sin A, it's BC over AC, which means it is 5 by 13. So the question B here, sin C. Sin C means I have to look from this side. Opposite of that will be AB divided by hypotenuse AC. But I don't have the measure of AC here. Since it is a right angle triangle, I can apply the Pythagoras theorem. AC square is AB square plus BC square. So 13 square is 5 square plus BC square, which will make it 169 is equal to 25 plus BC square. Shifting 25 on the other side, 169 minus 25 is BC square, which is 144 is BC square. So therefore BC is 12 centimeter. So therefore sin C value will become AB, which is 12, by AC, which is 13. So moving on to the next part, I have to find tan A in this. Looking at the diagram, tan A is its opposite by adjacent. Opposite for the triangle, go for the above reference. It's BC over AB. BC given 5 centimeter and AB being 12 centimeter. So the ratio tan A is 5 by 12. And the question D here is cos C. Cos C is adjacent by hypotenuse. For the angle C, adjacent being BC and hypotenuse being AC. So BC is 5 by 13. After that, I have to find secant square A minus tan square A. With reference to the above answers, cos C I have, therefore secant, sorry, I had cos C, sin A we had, sin C we had. I had cos C, which is 5 by 13. Sin cos A was not there. Okay. By the side ratio of triangle, secant A being secant A, which is hypotenuse divided by adjacent, AC by BC, which becomes 13 over 5, and tan A we have, tan A was opposite by adjacent, 5 by 12. So here I am doing tan square, secant square A minus tan square A. Secant square A becomes So the secant square A minus tan square A goes to be 169 by 25, and tan square A is 25 by 144. Secant square A minus tan square A is supposed to be 1. So secant square A means hypotenuse by adjacent, that is 13 by 5, correct? And tan A being 5, secant A being 13 by 12. Okay, there was a small error here, which is 13 by 12. Tan A 13 by 12. Tan A being opposite by adjacent 5 by 12, 25 by 12, 5 by 12, fine. Huh. So 169, 144. So 169 minus 25 is 144 over 144. Answer is 1. A note here, we have the ratio, trigonometric ratios are, like example, sine A is the ratio of opposite side divided by hypotenuse. So both being the length, so their units will cancel, and the sine A is a function with no units. And one more thing, we see sine square A, that is nothing but sine A getting squared. Looking into the next question, in a right angle triangle, if angle A is acute and cot A is 4 by 3, Find the remaining trigonometric ratios. So we have a right angle triangle here, and angle A is acute in that. Let me write the angle A here. B, let it be the right angle, and C here. And they are saying cot A is 4 by 3. Cot A, which is adjacent side divided by opposite side, that's 4 by 3. I have to find all the trigonometric ratios. So uh, for the angle A, adjacent side being AB and the opposite side goes BC, which means to say AB is 4 units and BC is in the ratio of 3 units. So by applying the Pythagoras theorem, AC square is AB square plus BC square, which becomes 3 square plus 4 square. That's going to be 9 plus 16, 25. AC square is 25. Hence, AC is 5. So we solved AC as 5. Therefore, let's write the remaining 5 trigonometric ratio. Sin A is opposite by hypotenuse. Opposite side by hypotenuse, where opposite is BC by AC, BC being 3, AC being 5. Next I have is cos A. Cos A is adjacent by hypotenuse. So that will form opposite is 3, adjacent is 4 over 5. That's because AB by AC. So next I have is tan A. Tan A is 1 over cot A. Therefore that forms 4 by 3 to 1 over 4 by 3. So I can simply write it as 3 by 4. Next I have cosecant A, which is a reciprocal of sin A. So sin A I have obtained 3 by 5. So 1 over 3 by 5. So it's 5 by 3. Then I have to find the secant A. Secant A is 1 by cos A. So it's 1 over 4 by 5. 5 by 4. So thus we got all the 6 trigonometric ratios. The next problems I will continue in the next video. If you are not yet subscribed, please subscribe my channel, like and press the bell icon. And also you can put whenever any topic in the mathematics or physics is required in the comment box, so that I will try to give solution or detailed notes or e-video content on that topic. Thank you for watching the video.